Hey guys, it's Sid. I'm back with another one, and today I want to talk to you about the differences between a data analyst, a data scientist, and a data engineer. So about 5 years ago, I embarked on my very first journey, my very first role as a data analyst. But since that time, a lot of things has taken place in the data industry, and we've seen new roles like data engineers and data scientists become very much hot in demand. I want to break them down, tell you a bit more about what the roles involve, how I've worked with data scientists more recently and data engineers, give you a bit more of a background and a bit more of a flavor on understanding whether or not you want to pursue these two exciting roles and what that could mean for you and your career. So without any further delay, let's make a start. So the first role is a data analyst, and that's a role that you guys will be more familiar with. It's a classical data role. This is a role that exists in just about most companies, and it's very often an entry point to which people can then pursue or progress in a data science or data analytics career. Most companies today hold and employ data analysts to help them get to grips with their data. Businesses today have a ton of information and a ton of data, and they need an entire team and more a giant workforce which is able to analyze that data and then translate it in a way that allows them to make business decisions. So what really matters for data analysts is that they're able to take data, do some insightful transformation to it, and then present back some information to the business that allows them to make a decision on what they want to do. Could be decisions relating to sales, could be decisions relating to spending, could be decisions relating to market share, competitors, customers, you name it. But the data analyst is a key classic role which just about every company will have, and more importantly for you guys, it means there's plentiful jobs. So definitely a data analyst role is the foot in the door to most careers. In terms of the mixture of work, very often what you'll find is that although you're a data analyst, you are actually spending a great deal of time doing a lot of business. So in terms of the exact mix, you're looking at about 40% data analytics and transformation and cleaning. You're also looking at another 40% which is spent doing more business meetings, taking part in project calls, business requirement meetings, presentations, and then remaining 20% is spent actually doing some core maths and statistics. So the role isn't pure data as such, no role really is. But the data analyst role is a good mix which allows for people to build their business skills, project management, data skills, and some statistical work as well. Now, in terms of tools, there's a variety of tools, but the most frequent and common tools used by data analysts, primarily you've got Excel. You've also got visualization tools like Power BI or Tableau, or increasingly Looker. And then thirdly, you might have a transformation tool, not always, but you might have a transformation tool like Alteryx. And then the fourth one is around key language, and very often the language that is being traditionally used by data analysts is the SQL language. And that allows you to query databases, retrieve data in the format and the depth of detail that you want. So SQL is used entirely just to pull data out of a database, but to transform it at the same time. Now, more and more data analysts are being asked to learn more skills. So obviously in 2023, we're seeing more skills emerge, and one of them is Python. So Python programming is very much a in-demand area and in-demand skill. So where data analysts are using Python, they're using it to do automation. So not really using it for machine learning, they're not using it for AI, they're not using it to test any machine learning models. That is done by the data scientist, but data analysts today are using Python to automate things and move things from A to B to C. So we'll cover more of that in a future topic, but just to give you a quick brief on the kind of tools that data analysts are using. My recommendation, so if you want to become a data analyst, it's the starting point. You definitely want to get a role as a data analyst before you progress further. Now, if data analyst roles are quite tough, then what you might want to do is look for a junior analyst role, or look at a business analyst role, or look at a project role even. Somewhere where you can get your foot in the door, do some business work, but at the same time kind of slowly move into that data space. So I've got friends and family who have become marketing analysts. They did work in Google Ads, they did work in data visualization, they did work in advertising, marketing, campaign management, and then they slowly found their way into core data analytics. So in terms of career progression, this is an interesting point. So to a lot of people, a data analyst role might seem limited. You can't really go beyond it. If you want to become more advanced, you have to go down the engineering route or the data science route. But to be honest, that's where a lot of people go wrong. Because if you look at big banks, for instance, where I used to work at HSBC, I work now at JP Morgan, a lot of people who started off as data analysts move their way up to becoming head of analytics or lead data analyst or senior data analyst. So these roles are now emerging. And what you'll find is the more senior you get, you're actually not taking on more data analytics work, but you're actually taking on more team responsibility. So you may be managing offshore teams, team in India, you may be managing teams in Europe. I used to manage a team in Poland, a group of data analysts there. So when I got my role, I found myself line managing very quickly. So in terms of promotions, you'll find that promotion pathways do exist for data analysts, but if you expand your horizon a little bit, you'll find more roles will come open to you and come available to you. Right, data scientist. Now this was once billed as the sexiest job title you could have. It was the most in-demand role at one point. Everyone wanted to be a data scientist. We're talking about 5 to 7 years ago now, when I first came across the role, and I read about the role in numerous articles online. I'll show a few of these up now on the screen. And the reality is that the data scientist role has actually evolved since then. And for a lot of people, it's more than just machine learning and AI and doing maths and core statistics. It's actually become more of a business guru as well. So the role actually today exists not just as a purely technical role, but one which very much helps businesses establish and understand whether or not certain things can be done in a certain space. So a data scientist today is still predominantly doing a lot of heavy work in ML modeling, ML development, ML training, do a lot of statistical work. So things like logistical regression, things like standard deviation. These are more statistical concepts. Now these are things you can study. They existed before the explosion of data. So these kind of people who did that kind of work were actually known as statisticians, and the teams that did them were known as econometric teams. So when I used to work at Nielsen, a media agency, we actually had an econometric team. Now a lot of those guys today are most likely known as data scientists, as the role has evolved. Now, I used to work with several data scientists in my previous role, and very often these people were very good with numbers. They were very good at understanding models, and I'll cover data models and ML models in another video. But they were very good in their niche field. So they often had like an interest in one thing and they stuck with that interest. So one of the guys I used to work with, he was a specialist in algorithms, and one of his favorite algorithms was XGBoost. And he always told me about this because it was an algorithm that he used on a project with Netflix. So a lot of these guys have got a huge interest in math, statistics, and modeling and machine learning, and you'll find very much that's all they do. So, and many of them are also very good at coding as well. So I used to work with one gentleman who was great at Python and another gentleman who was very good in the R programming language. So in terms of balance of work for data scientists, they only spend about 50% of their time actually training models, writing up code, looking at machine learning models, looking at algorithms. That's only 50% of their time. The other 30% of the time is actually doing some analysis, so taking the results of a given output from a model or a given output from a particular code or program they've built and disseminating that and translating that into business language or business value. And then lastly, the 20% is actually business discussion. So data scientists were often in meetings that I was involved in. We had a number of business requirements and we usually brought in a data scientist to see if they could build something that could really help us. So the reality is most data scientists are spending a great deal of their time actually doing a lot of business work, a lot of preparation, and many many data scientists, bizarrely, are stuck in roles which require them to do a lot of cleaning and preparation of data. And this is where there's a huge complaint from a lot of data scientists that they're not really suited to that kind of work, and this is where the data engineering role can emerge. So as I mentioned already, in terms of tools for data scientists, they're heavily involved in coding. So they use a lot of Python, they'll use a lot of R. R is another great language similar to Python, but it's got great statistical capabilities and modules. Sometimes they'll use SAS, which is a private company that have their own intelligence products. But very often they'll be using a lot of code, and they'll be spending a lot of time in applications which allow them to develop their code. So things like PyCharm, RStudio, which is now known as Posit. They'll also be using things like Jupyter as well. So where they can develop code in certain environments and frameworks, you'll find them using those applications the most. Now, many data scientists will know Excel, which is obviously a given, but not all of them will know data visualization in Tableau or Power BI. In fact, I worked with a gentleman who was a data scientist that had never used Tableau or Power BI. And that's because most of them do visualization in Python. So Python has many data visualization libraries, libraries like Plotly, Seaborn, just to name a few. There's many out there, but a lot of them would do their visualization entirely in Python libraries and Python packages. And more recently, more languages have appeared in the data science space. So one of the languages that many data scientists are exploring is Julia. Julia is known to be faster than Python, and it's got really powerful computation potential, and a lot of people are using Julia now to kind of do some of that heavy lifting, that heavy statistical work. So expect to see more around languages like Julia emerge over the next coming few years. Now, in terms of recommendation from me, I actually think the data scientist role is a bit overrated, and I'll tell you why. Where I've seen data scientists join a particular company, they've actually struggled. These people are often academics. They're academically minded, not business minded. So very often they've struggled in traditional companies. And the other problem you have is a lot of big businesses, particularly old traditional companies, they have a lot of data which needs cleaning, transformation, and needs a framework around the governance and use. And data scientists just aren't capable of doing that. So in terms of recommendation, I think it's a good role to become a data scientist if you love numbers, you love statistics, you're good at math, and you love everything around machine learning, artificial intelligence. It's definitely something you'd love to do if you've come out of university and you've studied data science at university, then it's something you'd really enjoy. If you enjoy more of the business and the business element and interaction with users and stakeholders and more of the business application of data, then a data analyst role may actually be what you want to stick with. And if finally you're interested in the way systems are built, in the way components are built, in the way flows are built from one to another in product building, then a data engineering role may be what you're more interested in. So as of 2023, the most in-demand role today is neither a data scientist nor a data analyst, but actually a data engineer. So data engineer roles have exploded. If you do a search on LinkedIn, you'll find hundreds and hundreds of data engineer roles, and all size of different companies are recruiting for data engineer roles, from big tech to small businesses and medium scale businesses as well. So the data engineer role today is a critical role. As businesses use more of their data and as the workforce around them use more and more data, there is a constant need of good, steady, quality data all the time. So this is where data engineers come in. They help with the supply of data. So data is typically stored in old legacy systems, big databases, which are hidden away, which no one can really access. Well, this is where data engineers come in and they build pipelines that make that data available. So what happens when that data is available? So you can use it for things like building data visualizations, data dashboards using the data. You can build reports, you can do querying, you can do modeling. You can even take that data and then transform it, translate it, or you can use it to train machine learning models as well. So with that data availability, a host of value is unlocked for a lot of businesses. So therefore the data engineer role becomes a critical role and remains a very much in demand role as of today. Now, in my previous role at HSBC, I worked with a very good data engineer who was based offshore in Poland. And this data engineer was really critical in helping me get access to data from a Hadoop big data system. Now, Hadoop is an old legacy system. It's slowly dying, but this gentleman, he knew how to code in SQL. His SQL skills were out of this world, and he was able to build a view for me. So he took the data from the database and built what I call a temporary table, which is known as a view. And he did that entirely in SQL. And once I got access to that data, I was then able to answer some business questions which a certain manager had asked of me. So this is where a data engineer can really help you, and also where it kind of proves that you don't have to know every single skill under the sun. If you have certain members of your team who have those skills already, you can leverage them to get your job done. So as a data visualization analyst, which I was doing at the time, I didn't have to learn SQL and become an expert in SQL. I had a data engineer on my team who could do that for me. Now, in terms of the balance of work, the data engineer will typically spend 60% of their time doing real building. So this is where you're moving data from one environment to another. You're building pipelines, you're transforming data, you are querying data, you're exploring data, you're doing a bit of analysis as well. But very often moving data, creating environments, creating products, creating schemas, database schemas, or establishing a relationship between one data set and another data set is about 60% of what data engineers will do. The other 30% is actually spent doing a lot of business analysis and project management. So data engineers are often involved when a new system is being built in, say, a cloud environment, or a new system is being built on a new platform. Data engineers will be brought in to kind of architect what the new system will look like. So this is where data engineers are spending about 30% of their time with project managers and IT managers doing some of that building and architecture work. And that actually only leaves 10% for data analysis. Data engineers are not expected to analyze data. They're only expected to supply it. So once that information and that data is supplied, it's up to data scientists and data analysts to use that data. So remember, a data engineer's responsibility is only to supply the data, never to really analyze it. So that's the balance that exists today for most data engineers. So typically data engineers will use big data platform and big data platform tools. So things like Apache Hadoop. They'll also use things like SAP or SAP. You use KDB. These are some of the platforms that most big organizations hold their data. You'll also find things like SQL Server, Microsoft SQL Server, Oracle as well. So some of the more classic kind of architectures and architectural products and platforms that exist. And in terms of coding, they very often will be coding in SQL. Not many will be using Python, but most of them will be using SQL to query the data and then to build new pipelines and move it from one system to another. But some of them are using increasingly Python to move some of their data and build new environments. So SQL and Python remain core languages of choice for the data engineer. And then more recently, we've seen a huge emergence in cloud computing. So a lot of data engineers are now having to learn cloud computing concepts. They're having to learn about Amazon Web Services. They're having to learn about Microsoft Azure and Google Cloud Platform, or GCP. There's a whole raft and portfolio of different tools within cloud computing. I'll cover that another day, but more and more data engineers are being required to know about different products that exist within each of those providers and vendors. And to that point, data engineers have great scope, because as cloud emerges and as cloud grows, cloud computing, another breed of data engineers is emerging, and that is the cloud engineer. So I see a future where data engineers will split into 2 or maybe 3, and one of them will be a cloud engineer route or cloud engineer profile or job. So guys, just to wrap things up, I've given you a quick insight and flavor of all 3 roles. They're actually very distinct and each serves a different purpose. If I was to restart my career all over again, I'd probably become a data engineer. Why? Because I love building things, I love creating things, I love working with old clunky systems, and I love building new ones entirely in the cloud. And this is what excites me about data engineering and the data science and data analytics space in general. Data is an ever-evolving field. There's more and more roles appearing every day. Data is in huge demand. We're seeing the industry really grow substantially, and there's a huge shortage of data skills out there. So if you can capture and gain those necessary skills to get yourself a role as a data analyst, scientist, or engineer, you'll already be onto a good and great head start. So definitely look to pursue one of those 3 career profiles if it interests you, and definitely look to study towards them, and I'll provide more content on this channel to help you fulfill your career ambitions. So guys, thank you for listening. Thank you for watching. Hope to see you on the next one.